ultrasonic technique. In this study, what is the special of this study, or we can say the significant novelty in this study? So normally, when we talk about the biomass, we need to extract the liquid product, what we call the bio oil or the jatopa oil or the palm oil, the liquid product, extract out the liquid product through various process. What is the various process? First one, much more easiest one or traditional process that we are using for maybe for the past 1,000 years is what? Mechanical pressing. That one you can really get the pure oil. Cannot, no matter it's from the rice oil, from any type of oil. That one is really pure oil. Yes. Still, until today, the industry is still using this process. I mean, one of the very common process is mechanical pressing process for the palm oil, for any type of oil, even for the coconut oil as well, using a mechanical pressing process. Second, you can use the chemical solvent extractions. For those are the chemical students or the chemistry students, you know, right? The process, the solvent extractions. What is the solvent extractions? Solvent extraction is, for example, you have a certain biomass. You want to extract out maybe the oil. Example, the oil contents or the certain content. Then you take the solvent that can absorb the oil content. For example, if oil content, we can use the N-hexane or the methanol as a solvent. Then from that, the oil can be extracted out by using the solvent. For example, we take about the hexane, extract out from the hexane or methanol. Then after that, we evaporate out the solvent. Then the leftover is the compound and the component that you or the product that you want to extract out. Now that is the second method. Then we have the many other method as well. In this study, we use the institute process from the extraction, and also the conversion. We do it together. So that as one step. So this is one of our work. Okay, the background. I don't want to go again. The background. I think most of you know about the background. Then the problem statement. There are two problem statements. First is the competition within the food and fuel. I don't want to go into detail. Then we go about the second generation of the oil. Then the second problem statement is what? The overall production process has to go through many processes, step by step. The extraction, purification, esterification, transfication, purification process. It takes around 70% of the total biodiesel production cost. Make the overall cost is higher. So that's why this is the conventional process, not economically feasible. So instead of we use the initial feedstock as the oil. I mean after the extraction, no matter the mechanical extractions or maybe the solvent extraction, but we use the in situ reactive extractions. I mean we use the feedstock directly. From these experiments to produce the biodiesel. So I didn't show you the objective here. Okay. Because you see, from the conventional process, the getoplastics, I need to go through the grinding and also the drying. This one is still the same process. After that, we need to use the N-hexane to extract the oil from the raw seeds. This one is using the chemical solvent extraction process. Then after that, we need to recover using the evaporator. Then after that, reactive. And this one, the reaction is go through two steps of reaction. I didn't show you here. The traditional need to go through the two steps of reaction. One is the acid catalyst esterification. The second step is the alkaline catalyst trans-esterification process. Then before we can go to the washing step and also the catalyst step. But our process, we just using one step to replace these two steps into the one step, but the other step is almost similar. So the objective of this study is what? To investigate the feasibility of the non-abrasives. In this study, we are using the Jatopa for the in situ reactive extraction with ultrasound. Ultrasound. Why ultrasound? So what is the benefit of ultrasound? Later I'll show you. Then we study what is the effect of the parameters for the ultrasound assist in situ esterification. One is esterification, another one is transesterification process. Then lastly, we do the characterizations of the getopasid before and after the ultrasound, and also the few properties of the biodiesel produced. This is one of my master student project. So this four objectives. Jatopa oil, I don't want to discuss in detail with the oil here. Just I mentioned around 1,500 kg per hectare only. Kg per hectare, with widely distributed around the Southeast Asia and as well as in the Africa and India. The oil could be 30 to 40, 35 to 40%. Come from the seed and also the kernel. Kernel is higher. So this is the methodologies that we design. First is the pre-treatment process. This pre-treatment process because the jatopa oil, jatopa seed or jatopa oil is relatively green, compared to other type of the oil. Example, compared to the calophyllum, we need to do a lot of the pre-treatment. For example, the regamming, the purification. But this jatopa oil, we didn't do much pre-treatment. We just grinding and also the drying only. After that, we go to the ultrasound assisted in situ esterification and esterification process without the extraction. But in this study, we have compared both using the chemical solvent extraction and also the direct in situ process. See what is the difference. What is the difference in terms of the properties, or in terms of the yields, or in terms of the purities. And after that, we compare that. This is the physiochemical property that we will compare. Okay, I didn't go discussion into the detail, so I directly go to the outcome first. If someone want to go into the detail about that study, you are feel free to go into that one. Is which study? Let me see. This study, the first study, all the detail result from not this study. Or the last one, this study. The number 3 and number 1, 3 and 1. This study has 3 and 1. Two study. This one is the preliminary study, then followed by the this one, the process intensified of the biodiesel synthesis. These two studies for those interested, they can go to these two studies, because sometimes I didn't discuss in detail here. In detail here.
Sir, I have a question.
Yes.
As you have used N-hexane and methanol to remove the extractives, although there are various extractives in the biomass you are using, and there are different solvents that can remove different sort of extractives. So how you will define that hexane and methanol will remove all the sort of extractives?
Correct. That one have to go back to your chemistry or chemicals concern. You need to identify what is the solvent for the certain products. That one, they have the list. For me, because I always do with the oil, then I know what is the solvent for the oil. But for the different compound, they have the different solvent. They have the very standard different solvent, or you can design your own solvent as well. But they have the list of the very common solvent for the certain chemical compound that you want to extract out. They have the list.
But wouldn't it interfere with the production of oil? Like if I am using if you are using hexane and methanol, it will just remove a certain sort of extractive, not all the extractives.
Yes, sometimes because sometimes other things when we attract together, then make it impurity. That's why you have to choose the correct solvent and correct target products that you want. That's the thing. So that other compound, other unnecessary compound will not attract, come together. Yes, you are right. So you have to make sure that solvent only attract your targeted compound, but not other compound. If other compound is extracted, you need to know how to separate it because sometimes cannot avoid. That is the only solvent that we have to extract this compound. But the compound B and C will come together. Then after that, how you going to separate the compound A with B and C? That one you have to further study. So that is your job to study, to investigate. Yeah, that's the thing. Yes, right. Correct. So this one I straight go to the result. Yes.
So for any chemical reaction with ultrasound and without ultrasound, does the solvent or catalyst change, or you can keep the same with ultrasound also?
Different.
So with ultrasound it will be different solvent, different catalyst.
You mean the solvent? Solvent same. Sorry, solvent same. I mean the result outcome will be different. Solvent is the same. Solvent is the same. Yes, solvent is the same. Yes. Solvent is the same. Solvent means what? Solvent means that solvent can take up that target product or not. This is solvent. Yeah, the function of the solvent. It can take up the certain target products. That is the function of solvent, but it's the same. It's the same. Yeah. Your question is correct. Maybe sometime, the temperature might affect the solvent. For example, the boiling point for the methanol, right? Will be evaporate at 60 degrees C. Make sure you don't heat more than 60 degrees C. If not, the methanol will be evaporate. That's the thing that you need to consider. If you use the methanol as a solvent, example, evaporation might be happen. So how you need to make sure they are mixed well during the reaction. Even though you want to use more than 60 degrees C, I didn't say cannot be used, but can be used. Yeah, because the evaporation might be happen. Yeah. So yeah, this one I just go straight to the result. You see, for any research, positive result, negative result also one of the outcome. I didn't mean that you have to report all the negative result, but what I want to make you clear is the negative result is one of the results. One of the results throughout your master or your PhD or even your research. Because why? You can let people know this one is not working. But of course, for master and PhD, of course you have to come up with one set of the success experiments. You only can prove that. You cannot say, I do 10 set also fail. What is your PhD work? Cannot be also. But the negative result also can be a result as a benchmarking, as a comparison. That's one thing. So you say, this one. So effect of the, sometimes we have to study the effect of the certain thing. Maybe they are not nothing much to change, but you show they are nothing much changing. You see, this one is what? Particulars, particle size. Particle size, we divide into the three categories. One is the particle size less than 1 mm, more than 2 mm, and between 1 and 2 mm. Between 1 and 2 mm. We found that this one, we look at the effect on what? Extraction efficiency, esterification efficiency, and frame year. What is that? Extraction efficiency is how many percent of the jatobah oil can be extract out. This one we call it the extraction efficiency. That means we calculate based on the total weight of the raw material. That means the total oil that extracted divided by total weight of the raw material. This one is the extraction efficiency. Esterification efficiency. So the main purpose of the esterification process is what? To reduce the acid value. As I told you, the non-edible oil normally have the high acid value and high viscosity. So the esterification is there to reduce the acid value. This one, the acid value, how much really? I think it's 18. 18 is 18. and we want to reduce to below, if for the biodiesel below 0.2 and 0.5, 0.5. Then then frame year that means during the esterification, some of the triglyceride, which is triglyceride is the chemical name for the oil, it's a common name, convert into the fatty acid metaester, which is fatty acid metaester, also the scientific name for the biodiesel, So how many percent? Because during the process, certain percentage will be converted already. So the true process to convert into the biodiesel is called it trans esterification, which later on in the following study I will show you in more details of what is the process and different processes. Then in that study we found that you see, if we have the particle size between 1 and 2, we can get more extraction efficiency. That means we can get more oil extracted out compared to more than 2 ml. You see, and this one also has the significant impact. So during your study, don't mix up any specific parameter might be possible affect your result. We don't know. We just try. We don't know. We just try. Oh, particle size. Maybe we just think that particle size will not have any effect, but you can go through the experiment to prove that they have the effect or don't have any effect. That is the thing. We don't know. Then we just try. Oh, we found that they have the big significant effect because why? If more than 2 ml, the mass transfer is limitation because difficult for the solvent to penetrate with the samples, with the samples. So with more even less than 2 ml, maybe between 1 and 2 ml, we have the largest interface area that facilitate the oil extraction. Then after that, even we find even final, go less than 1 ml, they are nothing much different. Because that is the optimal already. Nothing much different. Because if they are the 5 particles, maybe all your sample will be together already. Then make it the space, don't have the larger surface area already. This is the maximum limitation that the ultrasound can penetrate into the particle size. So that means we know that 1 to 2 ml is one of the optimal condition. We don't need to go into the smaller particle size. So this is one of the ways to do optimization.
Different feedstocks?
Different feedstock you have to see. This is for the Jato part. This one is for the Jato part. So this is one of the way I can do the optimization. We fix the other parameter first. Other standard parameters. That is a parameter that we fix. Then with the vary. So we can do one by one. This is one of the way to do the optimization. Then second, we can use the different acid sulfuric loadings. Acid sulfuric, we use the acid sulfuric as the what? As our catalyst. As our catalyst. So with other parameters, with the particular size, we fix as 1 to 2 because we know that 1 to 2 is the optimum for the for this case. So after that, we increase the loading. We find that the increasing the loading, the extraction efficiency almost stagnant already. So we know that the acid sulfuric will not have any effects on the extraction efficiency. You see, yes, from few experiments we can get many information, many information. So be more creative, in order to find out your output. You see, this one, just one experiment, we have 3 output. I draw up 3 different output. First output is what? The extraction efficiency, how many percent of extraction? Because sometimes, as I told you, they are not much different. Then second is esterification efficiency. Esterification, how many percent of the acid value will be reduced? Last one is the frame year. We can study the what is the intermediate result. Yes, we are not necessary to get the frame year at this moment, because the frame year we can get it after the esterification to make sure the frame year is more than 95% is sufficient. But we study because why? We want to investigate. We are the researchers. We are the scholars. We want to investigate every single parameter that might be have the effect. Then before that, increasing, enhance more esterification reaction. Of course, this one we know. From the chemical reaction, we know that if more catalyst loading on the process, the process will be more efficient. Correct? More efficient until the certain optimum value, which in this case is up to the 5%. So for the esterification process, that means the sum of the triglyceride will be converted, or free fatty acid will be converted into the fatty acid, which is the directly. So we know that the free beer might be much more affected, much more affected. Because why? You see, from here to here, you see, there is a significant change. Why? What happened? This one, I told you that the activation efficiency is the acid value, the conversion of the acid value. This one from here to here, we know that we can make the assumption that some of the FFA or free fatty acid are converted into the frame. So that's why from here to here, you see the acid value are reducing. Reducing that means what? The efficiency of the acidification efficiency is increasing. Maybe the acid value is reduced. And until the certain the acid value are almost maintained already. But if we prolong the reaction time, the acidification process, transfer process is a reversible process. You know, the reversible process. If you go backward process as well. Okay, then until here, before that 5% is the optimum. We can get the free years at 16.73%. So throughout the process, the water will be produced as a byproduct. That process, acidification transfer water will be produced as a byproduct. Water will cause the acid value increase as well. So this one is what we have the in this study we conducted more experiments, but I just show you a few experiments only. So this one is I think the last one for the acidification. This is the effect of the reaction time and also the ultrasonic amplitude. How many percent of the ultrasound can we rate? We use 40%, 50%, 60%, 70 and 80%. 70 and 80% is good. We know that the frequency is highest. That means what? The ultrasound can penetrate and penetrate directly to the sample.
More surface area is available for the reaction.
Correct. That's the thing. But we found that overheated. You know, our overheated and make the overall temperature also increase. It's not good. It's not good. Overheated. And also the more than 60 degree also not good, because why? More than 60 degree, the methanol start to evaporate already. The methanol will not have the reaction with the sample already, got evaporate. So and also so that we found that the 60 even though the higher frequency, the highest reaction time, the frame here will be keep increasing, but we take the 150 minutes and also the 60 degree as the optimal conditions. Yep. And also, you found that, you see, if we are using 60% of the amplitudes have the highest what faster rate, the reaction rate is much more higher compared to 40 to 50 degrees C. So this is the optimal condition that we obtain. Which is the particle size 1 to 2, 3 to 1. You see. Initially, this is the outcome that we get. The extraction efficiency is up to 83.96%, which is higher compared to the mechanical extraction process. In this study, I didn't here I didn't show you what is the. I don't know. I compare or not. We compare, but maybe I didn't show you here. We didn't show you here. Maybe can go to that paper because we compare between the traditional process and also the this process. The extraction efficiency is higher and also the acidification efficiency. Extraction is almost similar, but extraction efficiency is much more higher. So since since the acidification efficiency is 71%, which the acid value still more than 4. You see, as a rule of thumb for the biodiesel production, if the acid value is more than 4, that means what? What happens if we use the alkaline catalyst, alkaline acid neutralization? So soap will be soap will be produced. It's not good. So that's why in this case, so we use the slightly lower KOH to avoid the soap production. Then with the reaction time with only 15 minutes, then we can achieve the stream here. This one we also study the this is the yep. There is the benchmarking study that initial study that we take the parameters. Then after that, you see. Then after that, we study what is the effect of the KOH, which is the alkaline catalyst. With the additional of the catalyst, the sulfurification process will be happen, correct? Make the product very difficult to separate. The soap will be happen. So the frame here will be decrease beyond the 1.5%, and so solubility of the frame in the glycerol is increased as well. So that's why in this case we take 1.5% of the catalyst loading. Then from here we study the frame year and also the biodiesel year. You know what is the biodiesel year already? Okay, then the frame year. This one is what the effect of the methanol to the actified oil molar ratio. So from 9, 12, 15, and 18, you see, by the chemical reaction, we only need 3 more, 3 more of the methanol. But as I told you, the triactivation process is reversible process, the reversible process. It just put 3 more. Not all the compound or the triglyceride can push toward to the right hand side. The reversible process will be happen. So that's why we need to put the extra methanol. Then after that we need to recover back the methanol. Recover back the methanol. Yes.
After the process.
After the process, I need to recover back because by schematic chemical process only we need 3. This is ideal case. It's not going to happen in the real situation. You need to use the extra methanol, which we use up to 12%, so that we can see the optimal condition. So beyond the 12%, we have the over dissolution of the biodiesel and also the glycerol, because it's fine due to the shifting of the equilibrium toward the reactant side, which reduces the overall efficiency, because this is the reversible process. This one is what? The effect of the reaction time and also the ultrasound amplitude on the frame purification and also the biodiesel yield. So we found that the reaction time just 15 minutes can be complete the reaction. Yesterday I think I showed you the biodiesel production. Yesterday. It takes up to how many minutes? 60 minutes to complete the reaction, but the ultrasonic we only need 15 minutes. So the ultrasound also able to enhance the overall efficiencies of the process. So this is the overall final result. Then final result, which the acid value able to reduce up to 88%, which the previous we achieved 99%, and also the biodiesel yield is 85%. 85%. Biodiesel yield is compared to the raw material. Compared to the raw material. Then, in order for us to commercialize the biodiesel, we need the free yield more than 98%. Mean free yield, that means what? For your biodiesel, that means at least 98% is the fatty acid biodiesel. And it cannot be, have other compound. This one, of course, we need to measure by using the GCMS. So this is the list of the parameters and also the standard and SM standards. Oh, I didn't show you the standard, right? Because for any test method, for example, the density, the acid value, the fresh point, the calorific value, these all we can not to say simply measure. There are a lot of the method for you to measure. We need to follow the ASTM or TN standard, the measuring or the test method. We need to follow the certain test method. Because example, density. You can measure the density at 40 degree, 50 degree, or any temperature and any conditions, or the room temperature. But according to the ASTM standard, we need to measure at the 15 degrees C, so that the 15 degrees C can be fulfilled the certain density value. This is the test method. This is also very important because if you conduct the scientific research, the examiner normally will ask you, what is the test method you are using? The test method standards. Test method is first thing. Second thing, what is your benchmarking study? We always must have the benchmarking study to compare the baseline study. Your baseline study. What is your baseline study? How you make the comparison? This one is very important. So the baseline study. So this is some of the properties which the acid value still higher. You see in this study, the acid value that we conducted after the final product is still higher. We are able to publish as well because this is our result. This is our result. Not really fulfilled. This is our result. This is what we get. It is above the, because maximum can be 0.5 only. But can be used or not? Can be used. But if you cause the wear and tear in the engine component part.
Is there any tolerance on the benchmarks?
Okay, that one is based on the final biodiesel that we're using. For example, you see, even though this one is based on 100%, B100, I mean 100% of biodiesel. If you mix with the maybe 80% of the diesel with 20%, the overall acid value maybe might be 0.4 or whatever. Yeah, that's the thing. It means what? We cannot use the 100% pure biodiesel. This cannot be used like that in the system. Yeah, that's the thing. There are no tolerance. No tolerance for what? If we are using in the vehicle, no tolerance for the car manufacturer. Because no at all, because they will not have the warranty. We discussed with the car manufacturers, many different types of car manufacturers. So this is one of the very big hindrances also, because the car manufacturers will not have the warranty if you use a certain percentage of the biodiesel or whatever. Yes, that's the thing that we need to take it carefully. Yeah, that's the thing. Car manufacturers is one of them. Yeah. Not only so, in order for us to develop a policy, it's not really easy. So many stakeholders involved. Yeah, many stakeholders. That's the thing. So in Malaysia also same thing, because the maximum they allow us, the car manufacturer allow us is 20%. Because beyond that, they say no more warranty or whatever. Yeah. At this moment, but throughout the time, maybe the biodiesel that we produce is, as I mentioned, is closer to the fossil diesel. Then can be possible. Can be possible. It's quite possible. So this is the conclusion. Conclusion is just normal because we found that the parameter we already discussed in details for the esterification and transfiguration. Then this one I didn't show you. The seed particles were found to have smoke and intense surface before applying the ultrasound. After applying the ultrasound, disturb and also the irregular surface was observed. That means what? The irregular, that means what? The ultrasound able to break down the seed matrix, of the particles, so that it can be easily to be the thermal degrade. Can be easily thermal degrade because the ultrasound go through the sample directly. Then this one fulfill the exam, accept acid value. We just report whatever that we found. And with this result, we are able to publish two papers. First is the paper number 1 and number 3.